Hi everybody, thanks for checking out today's video tutorial. In lesson chapter 14, we're going to study surface area and volume again, and for section 3, it's surface areas of cylinders. Your learning target is similar to that. I can explain how to find the surface area of cylinders. So that's what we're going to talk about right away here in our key idea. Okay, so it says the surface area of a cylinder is the sum of the areas. So we're adding the areas of the bases and the lateral surface area. And there's a great picture here that kind of depicts that. So our bases are depicted in red. So the top and then the bottom. To me, think of like a can of soup is kind of what I'm envisioning when I'm thinking of a cylinder. So I got a top and a bottom. Those are my bases, and realize that those are both circles. And then you have this lateral surface. So now for our lateral surface, imagine that we're taking the wrapper off of the can, and it would be a rectangle shape. So that's kind of what I like to envision when I'm thinking about a cylinder. You could also think about like paper towel would be a good example of a cylinder. Like some water bottles would be considered cylinders. Lots of different types of cylinders here. And you might be asking, well, what is the use of figuring this out? One really good real life application that I can think about is packaging engineers. I know UW Stout has a degree in this. I actually have a couple of friends from college and even from high school that went into packaging engineering. And they really like their jobs, and they're doing really well for themselves, to tell you the truth. And this is something that they would definitely need to know how to do in their everyday life. But kind of getting back on track here, today what you'll use is this formula right here. This formula is really important. The sum of the surface area, that's what the capital S stands for, equals 2 pi times radius squared. That's the area of these two bases, plus the area of the lateral surface is 2 pi r times height. So that's because if you were to unfold this distance, this red distance on the top of my lateral surface here would be 2 pi r. So imagine that you're unfolding this circle times my height. So that's how we'd find this lateral surface. And then we'd add together our circular bases. So really, this formula is going to be really helpful for you. I'm going to keep writing it down today because I also think it's helpful for me. So example 1 says, find the surface area of the cylinder and round your answer to the nearest tenth. So I'm probably going to be using 3.14 for pi, but I'll kind of show you how I do that as well. First, I'm going to write down the surface area is equal to 2 pi times radius squared. That's the area of my bases, plus 2 pi r times my height. That'll be my lateral surface. Okay, so I'll try to color code it here so it's similar. So 2 times pi times my radius squared, so that would be 4 squared, which is 16, plus I'm going to add to that my lateral surface area here. So that would give me 2 times pi times my radius. My radius is still 4 times my height, and my height is 3. Okay, so from here it's really just I like to say plug and chug, but just do some calculations. 4 squared is 16. 4 times 4 is 16. Times 2 is 32. So I'm just going to call this 32 pi for right now. Plus 4 times 3 is 12, times 2 is 24. So I'm going to call this 24 pi. When I add 32 and 24, 32 pi plus 24 pi should give me, 56 times pi. And I can be a little bit more accurate. Now I can take 56 and I can times that by 3.14. And you should get about 175 point, and it says round to the nearest tenth, so 0.8, and that would be millimeters squared for the surface area of this. Oh, it kind of looks like a tuna fish can, right? So that's the top and bottom and the whole side. All right, why don't you use this formula and try the two on your own here to see what you come up with. All right, for number 1, you should get 180 pi, which is about 565.2 square yards. And maybe let's do this one together. 2 times pi times my radius is 3 squared, plus 2 times pi times my radius is still 3 times my height is 18. So that'll give me 3 squared is 9. 9 times 2 is 18, so this is 18 pi. And then this one I have 3 times 18 times 2 gives me 108 pi. That should be an addition sign. So 108 plus 18 gives me a total of 126 pi. So 126 times 3.14 should give you about 395.6 square centimeters for the surface area of this. Kind of looks like a paper towel. All right. If you need help on either one of those two, come and talk to me or phone a friend. Right, in example 2 here, we're finding the surface area, and it says how much paper is used on a label on the can of peas. So realize here that when we're talking about the label, we're just talking about the lateral surface area of the cylinder. We're not talking about the top or bottom. The top and bottom don't have a label, right? We're just talking about this lateral surface portion. That's the label. Okay, so our lateral surface area would be, we don't have to figure out the area of our two circles, so we're just going to use 2 times pi times radius times height. And we should be able to find the lateral surface area. Okay, so 2 times pi times my radius is 1, and my height is 2. So 2 times 1 is 2, times 2 is 4. So this is 4 pi, which if you multiply 4 times 3.14, you should get about 12.56. And we're in inches, so inches squared for the lateral surface area of that label. All right, example 3 says you earn 1 cent for recycling the can in this example. We earn 1 cent, 1 penny. How much can you expect to earn for recycling the tomato can? And assume that the recycle value is proportional to the surface area. All right, so we're probably first going to have to find the surface area here of the tomatoes and compare that to the surface area of the peas, and then use a proportion to find out how much we could earn for the tomatoes. All right. Now, when we're recycling the can, realize that we're talking not just about the lateral surface area anymore. We're talking about the surface area of the entire can. So we're going to have to use that first formula, the big one, where we find the surface area of the top and bottom, or the bases, and then that lateral surface area. I feel like I'm saying surface area too much. All right, so we've got S equals 2 pi times radius squared plus 2 pi times radius times height. Okay, so 2 times pi times my radius is 2 squared plus 2 times pi times my radius is still 2 times the height of this can is 5.5 inches. Right? 2 squared, 2 times 2 is 4, times 2 is 8. So 8 pi plus 5.5 times 2, 11, times 2, 22. 22 pi for a grand total of 30 pi. And I'm just going to leave it like that for now, for the surface area of my can of tomatoes. Now, I'm going to need to find the surface area of this. Remember, I just found the lateral surface area. And the lateral surface area was 4 pi. So I just need to do 2 pi times radius squared plus, I already found my lateral surface area was 4 pi. So my radius in this one was 1. So 1 squared, 1 times 1 is still 1, times 2 is 2. So that kind of simplifies that. This would be simplified to 2 pi plus 4 pi, which would give me 6 pi. Okay, so for my p's, my total surface area is 6 pi. For my tomatoes, my total surface area is 30 pi. Now the question says we earn a cent or a penny for recycling the peas. Right? How much can you expect if these two are proportional? That the recycling value is proportional to the surface area. Well, let's set up a proportion for that then. I know that my tomato can surface area is 30 pi. I want to find out how much money I can earn for recycling that. I don't know that yet, so I'm going to call it X. That has to be proportional to my can of peas, which is 6 pi. And I know that I earn 1 cent for recycling that. And some of you guys could probably see a little bit of a relationship here, saying, okay, well, the relationship here is that my can of tomatoes is 5 times bigger. So if it's proportional, I can earn 5 times as much money. So 5 times 1 cent is, well, that's 5 cents. You can earn a nickel for recycling this can of tomatoes. Now, say you didn't think about it that way. Well, you can still use cross multiplication here. Okay, so if you did that, you'd get, let's see here, 30 times 0.01 has to be equal to 6 times x. Okay, 30 times 0.01 will give you 0.3. You just move the decimal 2 spots. 0.3 equals 6x, and then divide by 6 on both sides, and x would equal 0.3 divided by 6 would give you 0.05. The same way we did it. Same answer we got for just kind of thinking about, okay, 1 cent for 6 pi. This can is 5 times bigger. And notice I did not multiply by 3.14. I just added a pi on the end, and it kind of made the problem a little bit simpler. Okay, so you can expect to earn 5 cents for recycling the tomato can. All right, last on your own here, please pause the video now to try these out. Example number 3 says, what if in examples 2 and 3, the height of the can of peas is doubled? So this height now turns to 4. The question says, does the amount of paper used in the label double? So instead of having 2 inches, you'd have 4 inches. Okay, so 4 times 1 is 4, times 2 is 8, so that'd be 8 pi. Is that double what our original was? And some of yours can see that that's definitely yes. 8 pi is definitely 2 times 4 pi. And then letter B says, does the recycle value double? Okay, well, remember that when we calculated that was only the lateral. When we calculated the label size, that's only the lateral surface area. Okay, the label was only the lateral surface area, not the entire surface area. Okay, because the surface area of the can does not double, the recycle value does not double. So that's a no. I'll say that again. Only the lateral surface area is doubled. Because the surface area of the can does not double, the recycle value does not double. So that would be no. All right. That does it for surface areas of cylinders. Again, I'm kind of thinking about soup cans or water bottles or anything like that. Packaging, you definitely need to know something about this, but I can see it has more applications as well. That does it for 14.3. Let me know if you have more questions. I'll see you guys later.